I want to talk about question 9 on the, no, question 10 on the handout, parts B and C, because there's a bit of a trick to these. So, question 10, part B, there are three x-intercepts. The one is really obvious. It's -5. You know, you put -5 in here for x, you're going to get 0. So that's one of your x-intercepts. Well, the other factor isn't x minus 9, it's x squared minus 9. So when I set that equal to 0 and I solve, I would add 9 to both sides. And then I've got x squared equals 9. Well, one way to solve this is you find the square root of both sides. And the square root of 9 is 3. And when I find the square root of both sides, I got to make sure I look at both the positive and negative numbers. Because, look, if you took 3 and you squared it, you'd get 9. But if you took -3 and you squared it, you'd still get positive 9 because -3 squared is positive 9. So there's my three x-intercepts, -5, 3, and -3. Now if you look at part C, it's extremely similar with one tiny difference. So one x-intercept is easy, it's -5. But when I look at the other one and I do x squared plus 9 and I set that equal to 0, I'll subtract 9 from both sides, get -9. And then I'm looking for a number times itself that will give me -9. So even if I did -3, that wouldn't work because -3 times -3 would get me back to positive 9. When I take the square root of this, I end up with a negative number inside the square root. And whenever that happens, so like I have the square root of -9, I can rewrite it using I, the imaginary number, which represents the square root of -1. And so this would end up being x could be plus or minus the square root of 3i. I mean, if you're a little confused about this notation here at the bottom, we'll talk about that some more. But the main idea I want you to get is the other roots are imaginary because I'm trying to find the square root of a negative number. So I only have one x-intercept, -5, because these other roots I just found are imaginary. They will not show up as x-intercepts on the graph. Alternatively, you could have graphed both of these into Desmos, and that would have been another way to kind of figure out, like, okay, how many x-intercepts are there? And you would see like this only crosses at -5, while this other one crosses at 3, -3, and -5. So I just wanted to talk a little bit about those two problems because they're almost identical except for this -9 and this +9, but you can see the end result gives us much different answers in terms of the number of x-intercepts.